I will be explaining you Gallai's theorem in this video, but I don't explain you the proof here, okay? Just before entering into the proof of Gallai's theorem, you have to know something more general. Only if you know all these things, you can understand what is there in the proof. Otherwise, you will be put into the situation to mug up each and every lines, okay? That should not happen. That should not happen. So that is why before going into the proof, we have let us know something more important related to the proof of Gallai's theorem. Okay, so here in the statement of Gallai's theorem, look at this. If delta greater than 0, then alpha dash plus beta dash is equal to small v. That is what we have to prove. So before entering into the proof, you have to know what is delta greater than 0, and then you have to know what is alpha dash, what is beta dash, and what is small v, right? So let us learn one by one. First, what is delta greater than 0? Delta greater than 0 means delta greater than 0. What they are trying to say from this is they are talking about degree of the vertices. It means they are saying degree of the vertices present inside the graph should be greater than 0. That is, for every vertex every vertex should have degrees. It means what? Some edges should end, okay, 1 or 2 or 3 or for anything more greater than 0 edges should be incident on each vertices of the graph you are going to consider to prove this theorem. Okay, that is what delta greater than 0. And then you have to know what is called alpha dash. Okay, alpha dash means number of edges. I will write that for you. Number of edges. You can also make note of it. Number of edges in a maximum matching. Okay, what is alpha dash? Number of edges in a maximum matching. Then I will tell you what is beta dash. Beta dash means number of edges. This is also number of edges in what? Minimum edge covering of G. Minimum edge covering of G. Okay, so this is what alpha dash and this is what beta dash. Alpha dash means number of edges in maximum matching. Beta dash means number of edges in minimum edge covering. Okay, so here you have to know what is called maximum matching, what is called minimum edge covering, right? I'm saying all these things, but to understand it clearly, you have to know what it is first, right? I will explain you that also. Okay, let me erase it and I am going to explain you now maximum matching now. Okay, I don't give you proper explanation of maximum matching here because already I explained all those things. Okay, you can see that videos on my graph theory playlist. Go and check out it. Okay, so here I will be explaining you only something that is very important in our proof, in the proof of our Gallai's theorem. Is that clear? Okay, listen. Maximum matching, right? We are talking about maximum matching. In our proof of Gallai's theorem, you will have a graph. Okay, I will draw that. Oh my god, the space. Let me erase it and I will draw it clearly. Okay, this is a graph. Drawing, put this line is passing through this edge. Okay, and from this vertex, okay, have a graph like this. Using this graph, this graph is the hero of the hero of this proof, I can say, okay? Because each and every step depends on this graph. Let me give the names to the vertices. V1, V2. It's also vertices. This is V3. This is V4. This is V5. This is V6. Can you see that? This is V7. This is V8. Okay, these are the vertices. And now I will mark the edges. E1, E2, this is E3, this is E4, E5, E6, E7, this is E8, this is E9. Is that clear? Any doubts? This is the graph, our graph G, okay? So here from this I am going to write the maximum matching, okay? This proof you will denote maximum matching as M. Okay, I am also denoting like that. I will write maximum matching from this graph. Let me write that E2, E5, E9. And I am saying this from the edges set. I have wrote some of the edges here, and I am saying this is the maximum matching of this graph G. Okay, so here you know that what is maximum matching. All the edges present inside this matching, inside this, should not be adjacent to each other. That is the condition of the matching. And this, if you check it, then this matching will satisfy that condition. Here you have E2, right? I am marking E2 here. And what is E5? Here you can see E5. To show you, I am drawing this to show you that these edges are not adjacent, okay? E9 is this. Look at this, they are not adjacent, right? So I can say this M is a matching, and I will say this is a maximum matching, because you can't write some other matching that have more than this number of edges. Here you have 3 edges, right? You can't write a matching with more than this number of edges for this graph. Okay, only you will so that this is called maximum matching. You can't write the matching for this graph with more than 3 edges. So that is why this is called maximum matching. Can you get my point? Okay, and then I hope you can understand maximum matching from this. And then let us pass on to beta dash. Beta dash means what? Beta dash means, I explained you, number of edges in a minimum edge covering of G, right? So to understand it, you have to know what is called minimum edge covering. Okay. So here you are marking it as, okay, minimum edge covering I am writing. I am giving name to it, that is L, okay. The number of edges in maximum matching is alpha dash. It means if alpha dash is equal to what here? 3, right? Okay, let me write the minimum edge covering, okay. So edge covering means, okay, I am writing E2. Can you see that? E2. Ignore the background sounds, okay. If I look at all those things, I could not post even a single video. I love to explain, that is why I am making these videos. So if I commit any mistakes, please tolerate my mistake. Okay. E2, I am also a student like you. L is equal to, so consider me as your friend, and you can forgive me, right? Okay, let us continue. L is equal E2, E3, E5, E7, E9. I am going to say this is a minimum edge covering of this graph G. Okay, how I can say that? Edge covering means, here these are some of the edges, right? I am going to say this is the edge covering of this graph G. I will tell you how. Look at this first. What's the first edge? E2, right? For this edge E2, look at this E2 here. Look at the edge E2 here. This is E2, right? You are having, sorry, I committed mistake. You are having some of the edges, right? Okay, you have to check the vertices here. Look at the vertex. Start from the vertex V1. What I'm telling you now, I'm telling you is this is a edge covering of this graph G. That is what you are testing now. Okay, so let us test. You have to, this is the edge covering, so you have to check the vertices. If it is a vertex covering, you have to check the edges. Okay, this is edge covering, so I'm checking vertices. The first vertex is V1. So look at this V1. From this vertex V1, two edges are going, right? So E9 and E1. At least one edge, okay, that incident on this vertex V1 should present in this L. Okay, so here you have E9 and E1. Here you have E9, right? So the vertex V1 satisfied the condition. Now, look at this vertex V2. From this vertex V2, you are having the two edges incident on this vertex V2. That is E1 and E2. Let us check is there is E1 or E2 in this set. E2 is there, right? So V2 is also satisfied the condition. Similarly, you have to check for all the vertices. Okay, all the vertices should satisfy this condition. Then only you can say what? What? This L is a edge covering of this graph G. Is that clear? Now, minimum edge covering means what? It will have minimum number of edges. Okay. You can't write less than this edges. Okay. If you write less than this number of edges, then that will not cover all the, that cannot satisfy all these, that cannot satisfy the property of edge covering. Is that clear? Is that clear? So this is the minimum. You can't, if you neglect even one edge from this, then then the conditions, it should not satisfy. It will not satisfy the condition of edge covering. So this is minimum, okay. So I hope you can understand that. What is, now you are, I think that now you are clear with what is alpha dash and what is beta dash. Using this only you will prove the theorem, okay. If you understood till this, then the proof will be easy to you, okay. So in the next video I will explain the proof.